Welcome to True Projects. In this video, we are going to explain about the project titled Smartphone App Usage Analysis, Datasets Method and Applications. The main goal of this project are to forecast smartphone app usage time and analyze the mood of user reviews. It is crucial in addressing the urgent demand to improve user experiences in the online environment. It uses a variety of machine learning models to provide developers and organizations with exact insights into app usage trends and user sentiment. The importance of this project rests in its capacity to address the issues surrounding app performance assessment and the interpretation of user feedback, ultimately resulting in improved app functioning and user pleasure. Voting classifier and XGBoost work together as a powerful extension to accomplish these objectives with an accuracy of about 88%. The main goal of the project is to create a reliable algorithm for predicting smartphone app usage time and app review sentiment. A wide variety of machine learning methods are used to do this. Algorithms like Navy Bias, Random Forest, SVM, Support Vector Machine, and others are used to precisely describe usage patterns for app usage time prediction. App review sentiment analysis uses TF-IDF embeddings and techniques like logistic regression and XGBoost to analyze user sentiment. With an emphasis on the high-performing voting classifier and XGBoost extension, these algorithms jointly address the issues of app performance assessment and user feedback interpretation, enabling data-driven decisions for app developers and enterprises. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, we import essential Python libraries such as Pandas for data manipulation, NLTK for natural language processing tasks, scikit-learn for machine learning algorithms, NumPy for numerical operations, and C1 for data visualization. And the second module is exploring the dataset. Dataset 2190 cholesterol.csv. Here the project begins by loading and examining the dataset named dataset 2190 cholesterol.csv. This step includes exploring the dataset structure, inspecting the data values, and gaining an initial understanding of its content. Third module is data processing and cleaning. In this module, data pre-processing takes place. It involves handling missing values, addressing outliers, encoding categorical variables, and ensuring data consistency. This step prepares the dataset for model training. Splitting the data to train and test. The dataset is divided into two subsets, a training set and a testing set. The training set is used to train machine learning models, while the testing set is reserved for evaluating the performance. Building the model for smartphone app usage time. This section focuses on creating machine learning models for predicting smartphone app usage time. Various algorithms are employed, including Navy Bias. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem, used to predict app usage time. Navy Bayes is efficient for text classification tasks, which could be useful when dealing with app descriptions or user reviews that contribute to app usage analysis. KNN, K nearest neighbor. KNN is a supervised machine learning algorithm used for classification and regression, relying on the similarity of data points. KNN can help identify patterns in app usage behavior by finding similar users and predicting usage time based on their neighbors' data. Bagging classifier. Bagging classifier is an ensemble learning technique that combines multiple Bayes models to improve predictive performance. It can enhance model accuracy by aggregating predictions from various Bayes models, which is crucial for accurate app usage predictions. Random forest. Random forest is an ensemble learning method that builds a multitude of decision trees and combines the predictions. Random forest is robust, handles complex datasets, and can capture intricate relationships, making it suitable for app usage time prediction. Decision tree. A decision tree is a tree-like model that splits data into subsets based on the most significant attributes. Decision trees are interpretable and can be helpful in understanding the factors influencing app usage patterns. SVM, Support Vector Machine. SVM is a powerful classification algorithm that finds the best hyperplane to separate data points into different classes. SVM can be effective in classifying app usage into categories or predicting usage time. Voting classifier. Voting classifier combines multiple machine learning models and takes a majority vote to make a prediction. Voting classifier can enhance accuracy by leveraging the strengths of various algorithms, making it suitable for app usage analysis. K-means. K-means is an unsupervised clustering algorithm that groups data points into clusters based on similarity. K-means can identify user segments with similar app usage patterns, aiding in user behavior analysis. DB-scan. Density-based spatial clustering of applications with noise. DB-scan is an unsupervised clustering algorithm that identifies clusters of data points based on density. DB-scan can help discover app usage patterns in user groups with varying usage times. Linear regression. Linear regression is a statistical technique used to model the relationship between dependent and independent variables. Linear regression can be used to predict app usage time based on other relevant features, providing a baseline model for comparison. Building the model for smartphone app review analysis based on TF-IDF embeddings. Here, the project moves to analyzing user reviews of smartphone apps. The goal is to determine sentiment analysis for app reviews, which includes the following algorithms. Logistic regression. Logistic regression is a statistical model used for binary and multi-class classification. Logistic regression is employed to classify user reviews into sentiment categories, positive, negative, or neutral, in order to understand app review sentiment. Random forest. Random forest is an ensemble learning method that combines multiple decision trees for classification and regression tasks. Random forest helps in capturing complex patterns in user reviews and improves sentiment analysis accuracy. Decision tree. A decision tree is a tree-like model used for classification and regression tasks by splitting data into subsets based on attributes. Decision tree can provide insights into the factors affecting app reviews and offer interpretable sentiment analysis. SVM, Support Vector Machine. SVM is a powerful classification algorithm that finds the best hyperplane to separate data points into different classes. SVM aids in effectively classifying user reviews into sentiment categories for sentiment analysis. KNN, K nearest neighbor. KNN is a supervised machine learning algorithm used for classification and regression based on the similarity of data points. KNN is applied to classify app reviews by measuring the similarity to neighboring reviews with known sentiments. XGBoost. XGBoost is an optimized gradient boosting algorithm that excels in classification and regression tasks. XGBoost is known for its accuracy and is employed to improve the precision of sentiment analysis for app reviews. MLP, Multi-Layer Perceptron. MLP is a type of artificial neural network with multiple layers used for various machine learning tasks. MLP can capture complex relationships in textual data, enhancing sentiment analysis accuracy. AdaBoost. AdaBoost is an ensemble learning technique that combines weak learners to create a strong classifier. AdaBoost helps in improving the performance of sentiment analysis models by combining multiple classifiers. Navy Bayes. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem, often used for text classification. Navy Bayes can efficiently classify app reviews into sentiment categories, making it suitable for sentiment analysis. Voting classifier. Voting classifier combines multiple machine learning models and takes a majority vote to make predictions. Voting classifier leverages the strengths of various algorithms to enhance sentiment analysis accuracy for app reviews. Training the model. This step involves training the machine learning models using the training data. The models are fitted to the training data to learn patterns and relationships within the dataset. Building the model with voting classifier and XGBoost, since it gives better accuracy comparing with other models, around 88%. Among the various models, a voting classifier and XGBoost are selected due to their superior performance, with an accuracy rate of around 88%. These models are chosen as the primary predictive tools for both app usage time and app review sentiment analysis. Flask framework with SQLite for sign up and sign in. This module implements a web interface using the Flask framework, allowing users to sign up and sign in. SQLite is used as the database to store user information securely. User gives input as feature values and review of an application. Users input feature values related to app usage and provide reviews of applications through the web interface. These inputs serve as the basis for prediction and analysis. The given input is pre-processed. Feature is processed using pandas and numpy array. Review is tokenized and transformed with TF-IDF. The input data from users goes through pre-processing, including feature processing using pandas and numpy for app usage and tokenization with TF-IDF embeddings for text reviews. Trained model for prediction. The previously trained machine learning models, particularly the voting classifier and XGBoost, are used to predict app usage time and app review sentiment based on the pre-processed user inputs. Final outcome is displayed through front end. Finally, the results of the predictions and sentiment analysis are displayed to the users through the front end of the web application, offering valuable insights into app usage and review sentiment. Comparison graph. This is the accuracy comparison graph. On the x-axis we have the accuracy score, and on the y-axis we have different types of algorithm. And from this graph we can say that XGBoost performs well. Execution. For the execution of the project, we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file. These are model files which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Open the Anaconda prompt. Use the cd command followed by a space and then paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and port. Now copy the local link. This is the local link. I'm copying the link and paste this link into any web browser. I usually prefer Google Chrome and hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up. If we are a new user, first we need to register. But I have already registered, so click on sign in. This is the login form. Enter the username and the password. And click on login. So this is the home page of the project. So here we need to enter the application name and all these details. By entering all these details, we can get the app usage time and the sentiment for the application review. Now let us enter these details. So here I have selected the application name as Call of Duty, and I have entered the day as 17, week as 20, day of week 4, month 5, quarter 2, year 2019, day of year 137, week of year 20. And this is the review for the application. Amazing. Now click on submit to get the app usage time and the sentiment of the review. So this is the result, the outcome. The predicted app usage time is 1 minute. And the message which we have given is amazing. The label for the message is the category type is positive. So this is the sentiment for this message. Now let us select one more application and enter all these details to get the app usage. So here I have selected the application name as Hotstar and I have entered all these details, and the review for this application is nothing. Now click on submit. So here we can see the outcome is the predicted app usage time is 0 minutes and the message here is nothing, and the label here is the category type is neutral. So this is the sentiment for the review. Now let us select one more application and fill all these details. So here I have selected the application name as MX Player and I have entered the day, week, day of week, month, quarter, year, day of year, week of year. And the review for this application is Waste app. Now click on submit to get the usage time and the sentiment for the review. So here we can see the outcome is the predicted app usage time is 2 minutes and the message is Waste app, and the label for the message is the category type is negative. So in this way, by entering all these details and selecting the application name, we can get the app usage time and the sentiment for the review, application review. And the conclusion of the project is the crucial responsibilities for smartphone app usage time prediction and app review sentiment analysis are successfully handled by this project, in my opinion. With a focus on the effective voting classifier and XGBoost extension, we investigated a wide range of machine learning methods and attained an excellent accuracy rate of about 88%. An easy-to-use interface is provided for entering feature values and app reviews by the Flash framework with SQLite connectivity. The pre-treatment procedures guarantee that the data is ready for model predictions. In the end, our project provides businesses and app developers with insightful data to improve app performance and user pleasure, enabling data-driven decision-making in the cutthroat app market. It is a potent tool for enhancing digital experiences and determining the best course of development.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.